Hello guys, welcome back to YT Classroom. I hope you all are doing well. Today we'll be solving the IGCSE Computer Science Paper 1 0478, Paper 1 Variant 2 from October-November 2024. This is the latest paper of this subject with Paper 1 Variant 2, and this is a really helpful paper if you're preparing for your May-June or your Feb-March series for the 2025 season. And this paper is of 1 hour 45 minutes, and the total mark for this paper is 75. And this paper covers the topics 1 to 6, which are essentially your theory topics for the IGCSE specification 0478. If you are new to this channel, do not forget to like, share, and subscribe for more helpful videos, especially on the 2020 October-November 2024 videos, as well as other exam seasons. Alright, now let's start. Let's move on to question number 1. So we have question number 1, which says that different types of softwares can be run on a computer. It says that what exactly is meant by software. Now here just a one mark question, so you don't need to describe a lot about a software. We essentially know that a software is anything like a program, or which is it can also be like instructions, a group of instructions that we can use or that we run on a computer so that we can operate the computer or the computer's hardware. So essentially software refers to programs, or you can say groups of instruction, whereas program is the most suitable word here. Programs that are used that are used and why do we use them? So that we can operate the computer and its hardware and its hardware. Okay, all right. Hope this question is clear. Again, we all know that software are basically certain programs that you have in your computer or your device, or basically programs are groups of instructions, as you see in terms of code. And these are softwares, and why do we use them? So that we can run the computer and its hardware. Utility software is one type of software that can run a computer. Take one box to show which software is the example of utility software. Now, utility software is essentially softwares that run in the background and they perform certain tasks which are might be necessary for the computer as well. So your spreadsheet is not a utility software; it's an application which will allow you to perform some specific tasks and applications. Antivirus, on the other hand, is a utility software. Web browser is not a utility software; it's an application as well. And database is again an application software. So obviously, you would select antivirus because antivirus is a virus that you essentially require so that you can ensure that your computer runs correctly, which is one kind of definition of utility software. Identify the type of software that manages inputs and outputs of the computer. Now, all inputs and outputs are managed by the operating system of the computer, which has many other functions apart from this as well. Operating system, or you could also say the system software. Examples of operating systems are Windows, Mac OS, etc. Then says that data storage can be measured using different units of measurement. Identify the name of the smallest unit of measurement of data. The smallest unit of measurement of data is basically called as bit, and we know that 1 byte is equivalent of 8 bits. So the smallest unit is a bit. State how many nibbles are there in 2 bytes. Now what does a nibble mean? A nibble basically means 4 bits. It's a group of 4 bits. And we know that in 1 byte you have 8 bits. So in 2 bytes you're going to have 16 bits. So when we do the math, if one nibble has 4 bits and 2 bytes have 16 bits, so obviously 2 bytes are going to have 4 nibbles. So we're going to say 4 nibbles. After that, we have the part C of this question, which says that a 10-second sound effect is recorded for a movie. It is recorded with a sample rate of 22,016 Hz and a sampling resolution of 8 bits. Calculate the file size in KB bytes. Show all of your working. So whenever we have this calculation of the sound file, what it do is the sampling rate, which is 22,016 Hz, into the sampling resolution, which is 8 bits, into your length of the sample in seconds, which is 10. All right. Now this is 8 bits, but if I want my answer in bytes, I can simply switch this 8 value to bytes. So I know that 8 bits is basically 1 byte. So I can write this down. If this will give my answer in bits, but I can simplify this so that I can write 22,016 into 1 into 10. So this will give my answer in bytes. Alright. Now, in order to understand the terms here, the sample rate refers to how many samples are being taken per second, and the sampling resolution refers to the number of bits they're used to representing each sample. So when I do the math over here, this is going to be 220,160 bytes. Alright. Now, obviously, you cannot use the calculator, and these calculations are a bit difficult without a calculator, but you have to do them at any cost, and this continues on in your AS level as well. So if I want to convert to bytes to KB bytes, I have to do 220,160 divided by 1024. Now what is this equivalent of? You should always try to simplify this first. You see that both of these terms can be divisible by 4. 1024 divided by 4 is 256. What is 220? If I do 220,160 divided by 4, 4 into 5 is 20. I have 20. 4 into 5 is 20. I have 1, 0, 16. 4 into 4 is 16. 55040. 55040. I can again simplify this by using 4. So this would be 64. And this 55040, if I divide this by 4 now, 55040 divided by 4. 4 into 1 is 4. You have 1 left, 15. 4 into 3 is 12. You have 3 left, 0. 4 into 7 is 28. You have 2 left, 24. 4 into 6. Alright, so it's going to be 13,760. 13,760. I still see that this can be divided by 4. So 64 divided by 4 would be 16. And 13,760 divided by 4. 13,760 divided by 4. 4 into 3 is 12. 1 remains 7. 4 into 4 is 16. 1 remains 16. 4 into 4 is 0. 16 again. So 3440. Now, if you simply do 3440 over 16, it's a much easier calculation. So 3440 divided by 16. 16 times 1 is 16. Now you could do 16 times 2. 16 times 2 is 32. You have 2 remaining. 24. 16 times 1 is 16. You have 885. So this goes to 215, and the value is in kibibytes. Kibibytes. So I write KIB over here. KIB. Kibibytes. 215 kibibytes. I'll just correct this and make this a bit more neater. KIB. So you always do ensure you're using 1024, or as per stated, if it's kilobytes, then use 1000, and do practice these calculations, as it's very guaranteed that you'll have a question of these in your exam. Moving on. It says that the sound effect file is compressed for storage. So what does compression mean? Again, so one mark question, so you don't have to describe much. You basically say that file compression, it refers to reducing the size of a file. File compression is nothing but it's a technique that helps you to reduce. File compression refers to reducing the size of the file. By compressing a file, you reduce the size of the file. Now, what is the benefit of compressing the file in terms of storage? So we do know that the smaller file, the storage, or like the file size decreases, so it takes up less storage space. It takes up less storage space. Again, compression is basically reducing the file size, reducing the size of the file, and the benefit is that it takes up less storage space. Question number 3 says a user sent data that is hexadecimal into a computer system. The data is converted to binary to be processed by the computer. Now, what is one similarity between hexadecimal and binary? A very easy question, and we can say that they both are number systems. Hexadecimal and binary, they both are number systems. Now it says that gives two difference between hexadecimal and binary. The main two differences between hexadecimal and binary is that binary is base 2 number system, as we know that, base 2 number system, whereas hexadecimal is base 10, base 16, whereas the hexadecimal is base 16 number system. Another thing to understand is that the binary only uses two digits. Binary only uses two digits. And what are the two digits? That are basically 0 and 1, 0 comma 1. Whereas hexadecimal, it uses 0 to 9, which are 10 digits. Hexadecimal, as we know, hexadecimal, it uses 0 to 9, which makes 10 digits, and the remaining 16, 0 to 9, and A to F in capital. Alright. It says that data that is denary can also be converted to binary. Give the binary number for each of the three denary numbers. Now, whenever you want to convert a binary number to denary number, all I like to do is write up a simple column with the headings 128, 64, 32, 16, 8, 4, 2, 1. If I want 15, I look for the value that is the lower than 15, which is 8. Okay, now 15 minus 8 is 7. What is the value that's lower than 7? It's 4. 7 minus 4 is 3. What's the value that's lower than 3? It's 2. And what is the value that's lower than 2 is 1. And when I do 8 plus 4 is 12, 12 plus 2 14, 14 plus 1 is 15. So I would write 0, 0, 0 on these sides, and just write 0, 0, 0, 0, 1, 1, 1, 1. Now for 180, I know that the lowest value is 128, and when I subtract 180 minus 128, it's going to give me 130, so 50, 52. Okay, now 52, if I subtract from 50, if I write a 1 here, 52 minus 32 is 20. 20 minus 16 is 4. Alright, so this is how it's going to look like. I have 128, 128 plus 2 is 130, 160, 160, and then 178, 176, 180. 1, 0, 1, 1, 0, 1, 0, 0. 1, 0, 1, 1, 0, 1, 0, 0. Then you have 235. And when I do this, if I put a 1 here, I know that 235 minus 128 is going to be 107. 107 minus 64 is going to be 36 plus 7, which is 36 plus 7 is 43. 43 minus 32 is going to be 11, and 11 minus 8 is going to be 3. 3 minus 2 is 1, and 1 minus 1 is 0. So this is what it looks like. 1, 1, 1, 0, 1, 0, 1, 1. Alright, so yes, okay, that's correct as well. That's correct as well. Yes, indeed. So I guess as per my calculations, these three values are correct. However, if you do spot any errors, please do comment down below so that other people do not make a mistake as well. And please do practice these types of calculations as you can really scoring. And once you start practicing, they're really easy. Now we'll move on to this question, which says that denary numbers can also be converted to hexadecimal. Give the hexadecimal number for each of the three denary numbers. Now first we have 14, and we know that 14 is represented by if A is 10 in hexadecimal, B is 11, C is 12, D is 13. So obviously E is 14, not much to think about, easy question. Then we have 100. So we could do repetitive division by 16. When I do 16, now I know that 16 times 6 is 96, and the remainder would be 100 minus 96, which is 4. And I do know that I cannot multiply any whole number with 16 to get 6. So I would just write here 16. I cannot do, so I have 6 is come down here. Then I read it in this pattern, so I got 64, and that would be my hexadecimal number. Alright, now the last number is 250, so what I do is 250 Again 16. So 16 times 15 is 240. So when I do 250 minus 240, it gives me 10. Obviously, I cannot multiply any whole number with 16 to get 15. So I would just write 16, 0, and 15 would come here. Now, it would be written in this order, but obviously, since 15 and 10 are two-digit numbers, we're going to write them in this way. This is going to be A, like 10, because A is 10, B is 11, C is 12, D is 13, E is 14, and F is 15. So we're going to write it as FA. I hope this is clear. This is the working for you all. Next question says a binary integer that is stored and registered in a computer has a logical shift performed on it. Describe the process of the logical left shift that is performed on a binary integer. Now, the process of left shift is that every digit or every bit you could say is shifted or moved to the left, and in that what happens is the most significant bit or the leftmost bit will be lost, and when we move something to the leftmost bit, the rightmost is basically empty, so we replace that with a zero. All right, there's only two markers, so we can only use one of those 2 points. So what happens is we say that each bit or each digit in the binary integer, which is the like the name given in the question, each digit in the binary integer is shifted to the last, to the left. And what happens is that the leftmost bit, or no, you can say the most significant bit, the most significant bit is lost. Now, in order to understand this clearly, what happens is that, for example, you have a number in this column. If I take here, so if I take 128, 64, 32, 16, 8, 4, 2, 1, and if I put 1 0 1 0 1 0 1 0 1 1, okay, and if I shift this number now to one place to the left, what happens is that I would lose this because there's no value here. So this would become 0 1 0 1, and no, 0 1 0 1 0 1 1 0. So you see, with the leftmost bit has been lost, and the rightmost bit I have to replace that with a 0. So that's what happened in left shift. And what effect does this have on the binary integer? Whenever we left shift it, it multiplies by 2. So we say that the binary integer is multiplied by 2. Now the next question is, that is the left shift. If it's the right shift, it's divided by 2 for every single shift. A negative binary integer needs to be stored in a register in computer. Give the name of the number system that can be used to store the negative binary integer. The name that number system is basically called 2's complement, and in 2's complement basically allows you to represent negative numbers. What you do is that the leftmost bit, that is for example 128, is changed to negative 128. So now the values that are represented are negative 128 to positive 127. And if you put a 1 in the negative 128 column, you can always get a negative number. But if you get a 0, then you can always get a positive number. And that system is called 2's complement. Question number 4 says a student has a smartwatch. The smartwatch has built-in input-output devices. Now it says that what could be the two input devices? Obviously, the first thing would be touchscreen. We can see in all smartwatches they have a touchscreen so that you can access the different like the applications and stuff. And second is the microphone, so that is you can use that for a call or record a message, etc. There could be other examples as well. For example, you could say there might be a camera or there might be a sensor. What kind of output device? I think the most clear output device is a speaker because they might have alarms or a call ringtone, etc. The smartwatch, it has ROM, that is read-only memory. Now, why does it have ROM? The main reason that why it has ROM is that so that it can store the bias. Now the bias refers to the basic input output system, and it is essential for it to start up. You could say that to store the bias and to store the bootstrap, which are both again essential for your startup of the thing. Sometimes in ROM you might also have to store the startup instructions. So most of the computers nowadays use ROM so that they can store the bias, which is the basic input output system, as well as to store the startup instructions, which both help towards the starting up of the watch when it is closed or when it's powered off. So ROM is needed to store the BIOS and the startup instructions. The startup instructions of the smartwatch. You need to store the BIOS and the startup instructions of the smartwatch. So that's why what the BIOS settings are often stored in the ROM. And sometimes if you disconnect the battery, what happens is that the BIOS settings are reset. That is, like, they will be reset to the factory settings. But on the data on the ROM is usually permanently stored. Now, a smartwatch uses a text-based application that receives data from a cloud storage. Describe what is meant by cloud storage. Now, cloud storage, what is essentially involves is that there's a third party which owns a lot of servers in a remote location that store your data remotely for you. So, and to describe a cloud storage, we would say that it's a collection of servers that allow or that store data in a remote locations. Cloud servers. Now, cloud storage refers to a collection of servers, a collection of servers that, and what do the servers are that store your data, in a remote location. And who owns these servers? These are basically owned by third parties. They're they are owned slash managed by third parties. By third parties. Now it says that I didn't explain two benefits of application using cloud storage. So that means they're asking us that if you're using cloud storage to store the data of the smartwatch, what's the application? Now the essential thing is that a watch, if you store the data in the cloud storage, then you don't need like a secondary storage space on the watch, which means it is going to be like smaller in size. All right. So the first benefit is that secondary storage device, secondary storage device, which is essentially going to store the data permanently. Secondary storage device, which is store the data permanently on the watch, is not required. And why is that helpful? So that the watch can be kept small in size. So watch is kept small in size. Now, what could be another thing that is a benefit of using cloud storage? The another thing is that if you want to access the data, like for example a watch breaks, or if you have lost the watch, you would still be able to access the data from any of the device, because cloud storage data is accessible from any device as long as you have internet access and sometimes a username and password to your account for the cloud storage. So the data can be accessed from other devices, from other devices with internet access in case the watch breaks or is lost. The watch breaks or is lost. So I hope this part is also clear. Now we'll move on to next question. The next question says that a smartwatch only displays the time and the text messages. A student incorrectly describes his the stopwatch as a general purpose computer. Explain why the student's description is incorrect. Now the main reason why is that because the general purpose computer, it can perform a lot of functions, whereas the smartwatch, it only performs a limited number of functions. So that would be the only main descriptions as well. And you can also say the smartwatch is an embedded system, because an embedded system is like a machine which only performs a limited number of functions. So you can say that the student is incorrect. The student is incorrect as The watch performs limited functions. The watch performs limited number of tasks that performs, as mentioned, limited functions, making it an embedded system, whereas a general purpose computer, it performs a lot of functions. A general purpose computer performs a lot of functions. Performs a lot of functions. So I hope this part is clear. Again, it's a very easy question. Now we'll move on to question number 5, which says that a barcode scanning system uses check data to check for errors in the data input. Explain how the barcode scanning system operates and to check for errors. Now what happens is that whatever the data that there in the barcode, you use a check digit, you calculate a check digit from that, and how do you calculate the digit using certain algorithm, for example, module 11 or certain algorithm which is already fixed. And that check digit will be added to the rightmost end of the barcode, usually rightmost end. When you scan the barcode, what happens is the check digit is recalculated from the data using the same algorithm, and it's then you check whether these both check digits match. If they do match, then there's no error occurring, but if they don't match, then there's an error. So what we say is a check digit, a check digit is calculated. And how do you calculate it? From what type of data? Calculated from the barcode data. A check digit is calculated from the barcode data using a specific algorithm, using a specific algorithm. And what happens after you calculated it? It is added to the end of the data. It is added to the barcode. You should not say end because sometimes I use in other ways as well. It is added to the barcode. When the barcode is scanned, when the barcode is scanned. Now when you scan the barcode, what happens is that the same algorithm, the same algorithm is used to recalculate the barcode, is used not to recalculate whatever recalculating to recalculate the check digit, to recalculate this check digit. And after that, what happens is that if the check digits match, that is, if they both are the same, if the check digits match, then what happens if the check digits match? No errors occur by scanning the barcode. No error has occurred. No error has occurred while scanning the barcode. While scanning the barcode. Again, a very short explanation. You calculate it first, you add that to it. When you scan it, you recalculate it, you compare it with the digits. Now, after a barcode is scanned, the data is sent to the stock control system to update the stock value for the product. Then it will be decremented by the number of items purchased. The data is sent to the stock control using a serial simplex data transmission. Explain on the data. The serial data transmission is sent at basically down a single wire, and simplex means that it's sent simplex in the data transmission one at a time and one direction only. There's simplex, there's duplex, there's half duplex, which refers to variation. And serial basically means how many wires. There's serial and parallel, which refers to multiple wires. Simplex basically means that you send in one direction and one bit at a time. Half duplex would be both directions but not at the same times or not simultaneously. Full duplex, both directions simultaneously. Serial, one bit at a time, and parallel will do multiple bits at a time. So you're gonna say that bits are sent, bits are sent one at a time because using serial, bits are sent one at a time, one at a time down a single wire. Bits are sent one at a time down a single wire, and the data is sent in one direction only. Again, serial means you send the data in one direction only, and simplex means that you send the data one bit at a time, only in a single wire. So simplex means that you send one bit of data at a time down a single wire. Serial refers to single wire, and simplex refers to one bit of data at a time along the one direction only. And other methods are that you can use simplex, half duplex, or full duplex, serial, or parallel. Any of these combinations will go with each other. Final time repeating, it could be serial or parallel. Serial means one bit or use only one wire, parallel multiple wires. Simplex, you can only allow bits to be sent in one direction. In half duplex, you allow bits to be sent both directions not simultaneously, but in full duplex, both directions simultaneously. Let's say that explain why is serial simplex the most appropriate method. The main reason why it's because so the bits are when if you use a serial simplex, the bits are sent in an order, so which will ensure the data is not skewed. Not in skewed in the sense if you use parallel, that the bits might arrive at the receiving and they might or the stock they might appear in a different order, which will make them skewed. But if you send them only one bit at a time, they'll arrive in order, they're sent and they're received in the same order, so the data will not be skewed. The bits the bits are sent and received in order, hence they are not the bits are sent and received in order, hence they are not skewed. And also basically the data does not there's no requirement that you and also you see that it might be long distance away, like the stock control system and the barcode of where the product is scanned, the POS, they might be long distance away, and serial is always more reliable for long distances. So that could be an additional point. Another point could be that if you because there's no requirement for the data to be sent quickly, so the increased amount of speed which you get in parallel because multiple bits at the same time is not needed. I'm going to include this point because my first point will look similar to the point that I've said before. So I would say that the data does not need to be sent quickly. The data does not need to be sent quickly, and why there's no requirement as mentioned, the data does not need to be sent quickly, which is something that you get in parallel transmission. The data does not need to be sent quickly as increased, so the increased speed of parallel is not needed. So increased speed of parallel is not needed. I would repeat that to you. The two reasons why we use serial simplex is that first of all, the bits are sent and received in order. That is, you send one bit at a time, so you receive one the same bit. You don't need to rearrange them, hence no skewing of data. And also, the data is sent quickly. The data does not need to be sent quickly. There's no requirement that you want the data to be sent quickly, so you don't need to, have parallel data transmission to have the increased speed. Now, the data is checked for errors after it has been transmitted to the stock. Give two error detection methods you can use for this purpose. Now, one error detection method could be your parity check, that is, you count the number odd parity and even parity, and you say that the number of ones it will have in the data. If it's odd at the sender's end, it should be odd at the receiver's end as well. Other one could be ARQ, which stands for automatic repeat requests. Automatic repeat requests. That is, you send if your data has been received, you send a positive what do you call a message. Otherwise, you send a negative message. And if you do not receive a message, then you resend the data after waiting for the timeout period. And you keep sending it until they don't respond to the feedback or you have crossed a certain limit of automatic repeat requests. Automatic repeat, okay, my bad. Automatic repeat requests. All right. The next thing is you have to there's certain components and some things which are missing. We just have to arrange them. A component name, a send signal to manage the flow of data throughout the CPU. That's basically your CU, which is stands for control unit. Control unit basically sends signals to ensure that data is sent throughout and ensures the synchronization of data. We're gonna do the component names first. It stores the address of the data that is about to be fetched. The address of the data is always stored in the MAR. MAR stands for memory address register. Alright. Then it says that transmits the data between the RAM and the CPU. Between the RAM and the CPU, the only two tools like the data is transmitted using data bus. Alright. And then it stores an instruction when it will be decoded. Whenever instruction is decoded, it is stored in CIR, which stands for current instruction register. After that, it says that you define a program counter. The program counter, what it does is that it's basically going to store the address of the next instruction to be fed. It stores what? It stores the address of the next instruction that has to be fetched. It stores the address of next instruction to be fetched. Whenever you want to like fetch the next instruction, you fetch it. Address of the next instruction will find the program counter that will move to the MAR. The accumulator, what it does is that it stores the interim result for a calculation. That means while a calculation is performed, you need to store certain values and those are stored in the accumulator. It stores the interim result of the calculation, not the final result, and it's again temporary data storage, not the permanent data storage as well. All right. And who performs these calculations? The calculations are performed by the ALU, which stands for Arithmetic and Logic Unit. After that, okay, it says that a student enters a URL. So what is meant by URL? A URL again is nothing, but it's a text-based address for a website or a web page. It's a text-based address. That means it consists of like characters for a website, or it could also be a web page. Now, what could the different parts of the URL be? The URL, it consists of the domain. It consists of the protocol that is like HTTP or HTTPS usually. The domain name, that is like what is the website's name exactly. It could contain, for example, www.wikipedia.com, so Wikipedia that. And then you have the file name. The file name often refers to like what is the exact content. So I could say www.wikipedia.com, and if I have later something slash maybe about Ferrari, so Ferrari would be the file name because that entire page is about Ferrari. The student enters the URL into a piece of software that displays the web page. Identify the software. The URL is always entered the software which is called as the web browser. Alright, now it says draw another diagram to show how the web page is located and retrieved and displayed on that. So the diagram, it's pretty easy. What happens is you have the web browser here, that is like the software on the user's computer. You will have your DNS, that is the domain name server, DNS, and you also have what happens is the web server. Now there's communication, two-way communication between the web browser and the DNS, as well as the web browser and the web server and this. So first of all, what does DNS mean? DNS is domain name server, and it's a way to find out the IP address for any URL that we give. So what happens is you send the URL to this URL sent to DNS, and what it does, finds the corresponding IP address of the web server who's hosting this URL. Searchings, what it does is it searches for a matching IP address, that is the IP address of the web server that is hosting this web page or the website IP address. Now what after it's found, it sends back the IP address. IP address is returned to the web browser. Now once we get the IP address, that's on the, so this is step 1, this is step 2. After that we communicate. So this is my step 3. you send a request to this, that I want this web page. You send a request to the web server. Request sent. How does the web server respond? It's basically going to send you the web pages which are sent back to the web browser. I hope this is clear. Now, sometimes what happens is DNS cannot actually find a web page in its directory or its database. So it sends it to another DNS, and if that DNS finds it, it sends it back to the original DNS, which then adds it to its cache and then sends back to the web browser. And this could be added if you want to, make your diagram better. An example of this given in the marking scheme. Okay, complete the data for the web page is transmitted using secure socket layer protocol. Now, in secure socket layer protocol, what happens is that the web browser, like the software on your computer, it asks the web server to identify itself, the web server. And how does it identify? How does the web server identify itself? The web server sends back its digital certificate. The web server sends back its digital certificate. That is like a certificate of authentication. After that, when it sends back the web browser, then it starts to authenticate the certificate. That means, is it a genuine certificate or no? If it is authentication, then what happens is that you have encrypted data transmission beginning. Encrypted again means that only the people who are supposed to have the data can have it. Other people do not have access to that data. All right, this is done. Now we move on to, I believe, the last question. So it said a robot vacuum cleaner uses sensors to navigate around obstacles. Take one box to show which sensor would be the most suitable for this purpose. Obviously, use proximity sensor to judge the distances between walls and objects to avoid collision between them. An expert system can be used to diagnose an error with the robot cleaner. Take three cover expert system. So expert system has a knowledge base, it has an inference engine, as well as it has a rule base. Knowledge base like all the data for it. The rule base consists of how like certain rules that must apply when you're making the inferences. The knowledge base is like the data on which you're supposed to make the inferences, and the inference engine is where these both are combined along with other rules and algorithms so that you can give the right, like the meaningful inferences and send them back to the user. Explain how the vacuum cleaner can actually make use of machine learning. So machine learning is basically when you learn through experience rather than being trained, you actually learn through perform the task. So for a robotic vacuum cleaner, what it do is that it could gather data, it could gather a certain amount of data, it could gather data while performing its task, which is vacuuming, while vacuuming. Now, obviously, we can't just end it here. We have to understand that what type of data would it be. And the data could be, for example, such as the shape of the room, so that you know it has a clear, like it has an idea that how is it to start, so that it can finish in the more quick way, such as the shape of the room. Or else it could also be where are the obstacles, that is like where are the furniture placed in the room so that it can avoid those parts. You can say position of obstacles or fixed objects, like or you can just say objects in the room. So it can make like a map so that it only goes to certain areas where there are no objects and saves time in the room. And maybe also you could also say what are certain areas that are way more dirty so that it can focus on those more areas, like with specialized cleaning tools or stronger cleaning or longer period of cleaning, and there's certain areas with less cleaning or which are less dirty, they could have less cleaning. Or which areas are usually more dirty. And this is how it learns through machine learning, usually more dirty. All right, and with this, I believe we have come to the end of this paper. So thank you so much for watching. Again, do not forget to like, share, and subscribe. If you have any doubts, any comments, or any suggestions for the next video, please don't hesitate to comment down below. I would love to have suggestions for my next video. And if you like my videos, I would really appreciate if you could purchase a super thanks or one of the subscriptions to my channel, which will help you a lot in your studies. All right, see you soon in the next video. Till then, take care. Bye bye.